Data showed the number of people who drowned by falling into a pool correlates with the number of films Nicolas Cage appeared in, with a correlation R equals 0.67, based on Taylor Wiggins' website and book Spurious Correlations. Researchers dream to have these high correlations, but not always have it. So does this mean that Nicolas Cage's films cause people to drown in the pool? Absolutely not. Today, I would like to introduce you to some key terms that you will need to know before you conduct scientific research, including hypothesis, independent variable, dependent variable, and some measurement issues. Hypothesis is the assumption or expectations that needs to be tested, and it can come from a theory or observations. The independent variable is normally denoted by X, and its variance is not determined by any other variables in the study. It is typically the variable we manipulate in the study, while dependent variable is the variable that represents the effect, and its variance is determined by the value changes of independent variable. For example, during crisis, the gender of the leader impacts the leadership effectiveness. Data showed number of COVID cases are systematically better in the countries led by women. In this example, the independent variable is the gender of the leader, while dependent variable is the leadership effectiveness. And in this study, the leadership effectiveness is measured by the number of COVID cases. So is this a good way to demonstrate the leadership effectiveness? Is this a reliable measure? Is this a valid measure? Check the description for the paper. Now I would like to talk about some measurement issues. Reliability normally refers to the consistency, while validity normally refers to the accuracy. For example, if I use a weight scale, and every time I stand on the weight scale, it shows a number around 100 pounds, 100.1, 99.8. It is consistent. However, does it reflect my real weight? Not necessarily, because I know my actual weight is 150 pounds. So then we need to talk about the validity, the accuracy. Let's use another example. So take a look at these three targets, A, B, and C. So in A, you can see the arrows hit the target consistently around a certain area. However, it's not in the center where we want it to be. So this is an example to show high reliability but low validity. It's consistent but not accurate. And then look at the second target, where the arrows hit out of the range and not consistent, not clustered. So this is a demonstration of low reliability and low validity. And take a look at the target C, where you can see that the arrows hit in the target and consistently. So it demonstrates high validity and high reliability. There are many types of reliability as well as validity. For example, we can test the reliability across time. We call it test-retest reliability. Or we can test the consistency across different people. We call it inter-rater reliability. No matter it's across time or across different people, we're testing the consistency. Or it can measure whether the results really reflect the outcomes of the variable, which we call it criterion-related validity. Check out this video for more details. As I mentioned earlier, by just looking at the data, sometimes it misleads us to believe one factor caused the other one. In Australia, data showed that whenever there are more people getting the vaccine, there are more COVID cases as well. Does it mean the vaccine caused the COVID cases? No. What are some possible explanations? So it could be because whenever there are more cases, people are more likely to go out and get their vaccine, which means the second factor actually caused the first factor. There might be some factors that can cause both. For instance, when the government policy changed, for example, when the mask mandate is lifted or more businesses are allowed to open, it can cause more people to go out and get their vaccine. It can also cause more cases. As I mentioned earlier, correlation is not causality. Let's keep that in mind. My name is Ning. This is your OB 101. See you next time.